Hello, everybody, and welcome back. This time, Chapter 5, Database Systems and Data Management. You're enjoying The Theater of the Mind by Professor Andy Molnar. I will be sipping some coffee throughout to make sure my voice continues to recuperate. So I enjoy my time with you, though. So let's get started. We already are aware from our work experience, or if not, I'll just say it, a strong data management program is needed to ensure high quality data and guide decision making along the way. So these are the objectives we'll be covering through this time we have together. I'll just gloss over them. You can pause and review them at your leisure. Excuse me. Because here's where I really want to get started. Why learn about databases? Okay? And that's an interesting question. The point about database systems is that it captures data and the changes to that data, just as important, that are occurring around us, and it's storing it, and it's updating it, it's making this data available so that as a corporation, we can make better decision making. And data, we'll talk about in a moment, in various other forms, takes different approaches. I have security data where I'm looking for specific things, but this kind of data, I mean in terms of business intelligence. So already think of data as useful in its category. I would not want to mix security data with business intelligence data. It will limit my ability to make changes in the future. And so the information systems employee or manager, such as yourself, will use data in a lot of ways in your day-to-day duties as data is captured and released. So database fundamentals, we'll just kick into that, right? Without data and the ability to process it, our organization can't really compete in the current business environment. We think of Amazon, we think of Netflix and others like that, right, who have paved and proven the way for database knowledge. Now, I want to make this note, data-driven decision-making, DDDM. Data does not make the decision. The decision is still behaviorally based, right? It's based on your experience. It's based on the corporate culture. It's based on the corporate and your own personal risk appetite, right? And risk threshold. So there are a lot of other things that go into the decision, but a good database, well-designed, organized, carefully managed collection of data, which is a database, is there to help guide that decision along the way. So before we get started, we want to first note some terms. Data is just raw. It's the ones and zeros. It's just this or that, right? And we collect it while we're building something or we're assessing. It's just raw. Data is raw. You should always think of the term raw when you think of data, because then I want you to think of information. Information is that raw data, which means nothing by itself, and it's analyzed, it's organized and processed and analyzed, and it provides additional value now because it becomes more fact-based. And then, of course, we can turn that into knowledge, right? And knowledge is the process of defining the relationships among the data, and that's going to require knowledge, which is an awareness and understanding of a set of information and the ways the information can be made useful, or the weaknesses as well of that information that we are looking at. These are some examples of data that we can use. Alphanumeric data could be logging data. Audio data might be recording of phone calls. Image or video data might be at an entry control point, for example. Lots of forms of data to be aware of and to assess as an information systems manager. Now, the key is that all the information that we gather should create value for us in the organization. And so this value of the information should be directly linked to decision makers to help them achieve the organizational goals. Again, the data doesn't make the decision itself. The data guides the decision, and your expertise, your risk treatment of making the decision, etc., rely on the decision maker. It's one of my pet peeves that people say, well, the data said. I don't care what the data said. How did you interpret it, analyze it, build it into the corporate culture, your own personal risk assessment, the company goals, etc. That's really where data it becomes useful. So there are benefits gained if we maintain high quality data. And notice I said if. Just because you have data doesn't mean it's high quality. The data could be legacy data, could be on a wrong system, right? There are lots of ways that maybe you didn't collect the data in an appropriate manner, right? Data collection. So there are lots of ways data can go wrong. And you should query and push your data managers and your analysts. How can they guarantee the accuracy of the data for the use that you're doing? Because if you have high quality data, I'm done with that diatribe, then you can improve decision making. And improved decision making means you're going to have satisfied customers, which should generally lead to increased sales along the way. Now, there are characteristics to high quality data, and some of the questions you would ask your data analysts about accessibility, accuracy, and completeness of the data. Is gathering the data economical? Some data is very expensive to gather. How important is it to your risk treatment and decision-making process? Is the data relevant? I already mentioned that. And is the data reliable? I also mentioned that, by the way it's analyzed. Is the data timely and verifiable? Other good points that you want to ask. So think of it this way. Let's make it personal. Have you ever received an incorrect bill or the wrong numbers on a financial statement from one of your banks, right? How did that make you feel? What was the process you went through to correct it, right? High quality data matters. Every time you want to open up a bill, look at it, confirm what you already think, and then throw it away. That's high quality data. And we make decisions based on our spending habits based on that. But if it's wrong, we will sometimes make the wrong decisions. We want to be careful with and make sure we have high quality data along the way. Okay, so again, and with that data, with higher customer satisfaction, with higher sales, with achieving corporate goals, we're going to improve innovation. Our workforce is happier because they're more productive. Their product is valued, right? So productivity generally increases. And we want to make sure with data that we ensure compliance. Very important. If you do work with any part of your data flows through California, you want to comply with CCPA, the California Consumer Privacy Act. If you do work and have any data that involves Europe, you want to be in compliance with GDPR. The United States, as we talked, I think in Chapter 4, has any number of laws like FISMA, the Federal Information Security Management Act, which deals with people who, the privacy and protection of data for U.S. citizens. So, for the U.S. population. So, compliance is usually its own organization separate from security. Usually have a compliance organization monitoring that data, doing data management, right? They would be key to all of this. And so, let's see. Oh, and so data has, yeah, I jumped out. There we go. Data has a hierarchy, right? So we've got to know the terms involved. So an entity is a person, place, or thing. We used to call that a noun, right? For which data is collected, stored, and maintained. That could be me. It could be you. It could be where you work. It could be where your home is. A file is a collection of these entities where it's me, where I work, where my home is, how much I make for a living, etc. An attribute is a characteristic of any entity. So an attribute might be people that make over $100,000 a year. Okay, and so that would be an attribute. And a domain is a range of allowable values of a data attribute. Here's what the hierarchy looks like. You have these attributes, which will form an entity, which build a file and create a database as a result. A couple other terms to be aware of. A data item, record, primary key, and a foreign key. I want to focus on primary key. Primary key is an attribute or set of attributes that uniquely identifies a record. So here's the problem with the database. Especially if you're merging databases or changing database systems. One of the biggest challenges is identifying that unique key, that one key that will define an individual record, right? And so the primary key might be at work your employer ID, employee ID. It could be your social security number to the federal government. But somewhere there needs to be a primary key that anchors or links uniquely the record. And sometimes that's a problem if not addressed up front. This would be an example of such a data hierarchy. Notice that eBay assigns an item number as that primary key to keep track of each item in the database. And that's how they make sure that only that data pulls up on that file when you are searching the eBay database along the way. Again, the primary key, it uniquely identifies the record. That no other record can have that primary key, right? And that's really an important point to emphasize. Okay. Now, today most organizations apply a DBMS or database approach to data management, right? Where what that means is that multiple information systems are going to share a pool of data, right? And a database offers the ability to share data and information resources without creating new systems, right? And so we create this thing called a DBMS, a database management system, which consists of a group of programs that provided by the DBMS supplier and are used to access and manage the database along the way. So here is a picture of what that might look like. So you have your database on the left, you have your DBMS, and notice HR is going to use their payroll program. If I'm in supply section of the company, I might use inventory, which is the third one down. If I am in accounts receivable, I might use the invoicing, right? So different people are going to use different applications, different offices, but all tapping through the DBMS, which ties into the database, which is going to have those entities, attributes, files that we just talked about, right? And that's how it's organized in that way. Okay. So, okay. So a schema then becomes part of what we're working on, right? In a relational database, a schema defines the tables and the attributes in each table. And it generates a relationship between those. And that's really what a schema is about. And a DBMS can reference the schema along the way. Oh, I think I went backwards. Oh, there we go. Back to schema. And that's really what that's about. Okay. And so we can have these various different sections, students and courses and the grades that they're going to get, right? And this is the activity of creating and modifying a database, in this case focused on students. And then, so we'll need a data definition language, or a DDL. The equivalent to a DDL is when we used to do DOS for an operating system, we'd have to load our own codes. Now we use a graphical user interface, so we don't have to do that. But in a database, we normally do load those